Hi, I'm Donald McIntyre, Operations Manager at Emerald. This is the Emerald Blockchain course, Class 9, How Proof of Work Works. As I explained in the video where I explained Bitcoin, the way machines across a proof of work blockchain reach consensus is called Nakamoto Consensus because Satoshi Nakamoto invented it. And it has these parts. One is that the network is constantly receiving new transactions, that those transactions are sent to all the other machines in the network, so they will have a full replication of the same data. The database in a blockchain is called a blockchain. The blockchain term is precisely the database. And to create blocks, the miners, which is a subset of the machines of the network, use proof of work to create a cryptographic stamp of the data of the new transactions that they're receiving all the time. In the case of Bitcoin, it's every 10 minutes, and in the case of Ethereum Classic, is every 15 seconds. And what they have to do is a lot of computational work, spending a lot of electricity to create this cryptographic hash, and this is why it's called a proof of work. Finally, the other part of Nakamoto Consensus is that usually the blockchains that use proof of work have a fixed supply of their coins. They pay a reward every block to miners. That reward is preset in their protocols, and eventually they're going to have a fixed supply of the coins. In the case of Bitcoin, it's going to be 21 million Bitcoins, and in the case of Ethereum Classic, it's going to be 210 million ETC. So the way what I just explained, Nakamoto Consensus works is the nodes in the network, they all receive new transactions all the time from users around the world, and whichever machine receives the transaction, they send it to the rest of the network. So every 10 minutes in the case of Bitcoin, or every 15 seconds, a block of transactions is accumulated. These transactions reach the miners because they are part of the network. So they reach the miners and they get the block of transactions, and they do a lot of computational work to create the cryptographic hash or the cryptographic stamp. I'm going to explain what they do exactly in the next slide. But when any of the miners, on average every 10 minutes in the case of Bitcoin, or 15 seconds in the case of Ethereum Classic, finds or finally creates the cryptographic hash or the cryptographic stamp for that block of transactions, then they put it together with the transactions and some other information and immediately send it back to the rest of the network. So the rest of the network fully replicates and makes a copy in every single machine of the block. They verify that it's correctly made, that the cryptographic stamp is correct according to the protocol, according to the difficulty, that the transactions are well formed, and that the accounts have balances, etc. And they add that last block to the blockchain, so the miners start immediately to work on the next block. This is a diagram of how Nakamoto Consensus works. So what do miners actually do? How it works? How does proof of work work? Well, what they are doing basically is every 10 minutes in the case of Bitcoin, or 15 seconds in the case of Ethereum Classic, each miner in the network, first they get the hash or the cryptographic stamp of the previous block, so they can go building a chain of blocks. They get the current transactions that have not yet been included into the network. They add a timestamp to know exactly at what moment the block was created, and they add another data point, which is an iterating arbitrary number, which is going to work in a way I'm going to explain now. So they get these 4 pieces of data, and immediately they start to work, spending a lot of electricity. For example, they create one cryptographic stamp out of this information, and if they hit this point here within all the possible numbers in the universe, and if this point is not within the target that is imposed by the network, then they have to throw away that hash and start again. And the way they do it is they change this random number or iterating number, and they try again. And say that if the miner tries again and hits here, it's still out of the target, so they have to try again. And they do this all the time. They do it hundreds of millions of trillions of times per second. They go trying with a different number constantly, and this is why they have to spend so much work. On average, every 10 minutes in Bitcoin or 15 seconds in Ethereum Classic, they have to try all the machines of the miners in the network. They have to try constantly, and the great majority of the time, they're not going to hit the target. And the target is sufficiently small to guarantee that probabilistically every 10 minutes in Bitcoin or every 15 seconds in ETC, one of the miners is going to hit the target. So if I am the miner and my machine has been trying trillions of times per second, and suddenly my machine hits the target, then my machine is going to realize this, immediately add the data of the cryptographic hash to these 4 components and send it as a block to the rest of the network, and they get my machine is going to get the reward. No? So this is essentially what proof of work is, or what the work is. No? The machines are constantly trying and retrying to it's like throwing a dart and trying to hit the bullseye. In this case, they have to hit a number within this very small target. And when they hit it, they send it to the rest of the network. And then the rest of the network, because they all know what is the current target, and when they receive the block and they see that, in fact, it has a hash from within this target, that is the proof that they know that a lot of work was spent spending a lot of capital and electricity by all the miners in the network. So this is the essence of the proof of work component of Nakamoto Consensus. The great benefits of this process is that it enables consensus between computers, because it's so difficult to hit the target, and whoever hits the target within the time frame in Bitcoin and ETC, for example, and when they send a block, it is extremely likely that that is going to be the correct block in the network. So when the rest of the machines in the network receive it and they verify that they hit the target, and that all transactions are correctly formed and they have balances, etc., they all reach exactly the same conclusion. Because if there's anybody else trying to commit fraud or an imposter sending false blocks that didn't do the work, it's very easy for the rest of the machines to realize that, because their hash is not the cryptographic stamp didn't meet the requirement, no, of the amount of work that they have to do, because they didn't hit the target. And this is how these blockchains for years have been building new blocks every time and reaching a perfect consensus. And they all have thousands of computers around the world without knowing each other, etc. They all have exactly the same copy of the blockchain, because proof of work enables this level of consensus. This same concept that the work itself is what provides the information to everybody to know which is the correct latest block, is also the way that creates permissionlessness. The first feature creates decentralization, and the second one is that this information provides a safe focal point of entry, exit, and re-entry. Why? Because if any new machine that wants to enter the blockchain and participate in the proof of work blockchain, just by checking all the proof of work per block, and they're going to realize that they all hit the target and that the work was done. And because it's so difficult to create an alternative chain, then everybody knows which is the correct chain. And if they were fraudsters or imposters sending different information, it would be very easy to check that they didn't do the work. So they're very easy to discard. This creates this easy entry and exit. Whenever a new machine wants to enter the network, they just check with the other nodes. They send them the blockchain. They check the proof of work, and they know that is the correct blockchain. And if for some reason they need to exit, or I'll say there's a blackout or there's a war somewhere in the world, and those machines have to exit and they need to re-enter again, it's very easy for them to check this again and join again the correct blockchain on a world, on a planetary scale. No? The same work has a third benefit, which is immutability, because uh, if the proof of work in a blockchain is accumulative. It's accumulated because, for example, in Bitcoin now we are by the block more or less 750,000 or 760,000. If somebody send a transaction on block 700,000, for example, 50,000 blocks away, and someone wanted to delete that transaction or modify it or change it or censor it, they would have to go to block 700,000 and rebuild all the other 50,000 blocks, spending a lot of capital on all the electricity again just to delete that transaction. So it's economically not feasible, and also physically very difficult because it would take them many months or even years to rebuild the 50,000 blocks. So the first feature creates decentralization because everybody reaches consensus without checking with anybody else other than the information of the proof of work. The second feature has the benefit of permissionlessness because anyone, as long as they have an internet connection, can enter and exit and re-enter the blockchain or the network whenever they want. And the third feature creates immutability because once a transaction is included in the blockchain, it's extremely difficult to modify. So all the accounts and balances and the smart contracts, they're all extremely well protected. The last benefit is that the cost of creating blocks equals the cost of creating the currency. So proof of work blockchains look to imitate the way gold is valuable in the real world, and gold is valuable because it's so difficult to extract from nature and so costly, and this is why it has value and it's scarce. So proof of work blockchains are called digital gold because the cost of creating the blocks, therefore the cost of paying the reward to the miner creating the currency, is equal to creating the currency. So that's why they're called digital gold. Again, so the overarching or the overall benefits of truly decentralized blockchains is decentralization, permissionlessness, censorship resistant, and immutability because of all of these benefits of proof of work. Thank you very much for watching this Emerald Blockchain course, Class 9, Proof of Work, how Proof of Work works. And please remember to download Emerald at emerald.cash/download. Thank you very much.